Hi, my name is Mike Gomez, and today I will be discussing my final project as part of the Digital Forensics course, which I call the FaceDetector tool. FaceDetector is a tool that will allow a digital forensics investigator to extract images from a hard drive image backup, namely a DD file, and then process these images through a face detection and recognition algorithm. Face detection in images should be useful for an investigator if he wants to limit his investigative focus to images that may identify either suspects or victims. Even though the tool relies heavily on computer vision algorithms, it does not develop new ones, but instead leverages existing algorithms to combine them to perform a specific function that the tool provides. The tool was developed using Python, which at execution launches a GUI. Here is a screenshot or snapshot of what the GUI looks like at launch, and it provides a few features, namely file locator, which allows you to select the evidence file for analysis, and in terms of analysis, what function provides extraction of images, facial detection, digit detection, which is an added bonus and wasn't part of the original scope of this tool, and face recognition. In terms of methodology for face detection is accomplished through the use of OpenCV, which is an open source computer vision library. OpenCV is a machine learning software which provides extensive computer vision tools and algorithms. For our particular case, we achieve face detection through object detection using a HAR feature-based cascade classifiers, which is provided by OpenCV library, which makes the developer job much easier. And for this particular case, the way they developed it is by taking a input image of a face and essentially detecting certain areas, namely the area of the eyes, and as you see here in this block, and also the space between the eyes, the nose bridge right here. So if it finds these two various blocks, there's a very high probability that it's found a face, and OpenCV provides various classifiers, which include eyeglasses or eyes, if you want to focus mainly on the eyes. But the one we particularly used for this particular tool was the frontal face classifier. Now, if once it's implemented, the tool will be able to accept an image, as we see here, that was extracted from the evidence image, and then perform a face detection and put a green box around it. So the precursor to face recognition was face detection. But we have to be able to process the image before we even could attempt to do a face recognition, because either the algorithm will be confused with all this other unnecessary images and data that's around it. So as part of the extraction, the tool will not only identify faces, but it will also extract the faces into a fixed size, as we see here, and then once it's done, then we can perform a face recognition against the face that was extracted from the image, and attempt to identify, link it to a specific name that is part of a database of potential suspects. Hence, the tool uses the concept of Eigen Faces to be able to do its face recognition part of the analysis. So in terms of the Eigen Faces, essentially what it tries to do is to find vectors that best account for a variation of face images in the entire image space, which it refers to as eigenvectors, and then it constructs a face space and projects the images into this face space, hence the name Eigen Faces. And a match is determined when in an eigenspace the eigenvectors distance is equal to each other. And I'll talk a little bit more about what exactly is meant by that a little bit later. So some of the challenges in working and developing this tool well, I'll list a few of them. Was being able, first one is selecting a computer vision library. Everything that I ended up using is open source, but there's a lot of choices to be able to choose from, either OpenCV, SimpleCV, and even PIL. And I was scared that I might go very deep into pick a particular library and find that I cannot complete the task, that I chose the wrong one. And with the limited amount of time we have in the summer, I was afraid I might pick the wrong one. Luckily for me, OpenCV seems to be very, very well supported. It has a lot of literature out there, and hence it turned out to be a safe choice for developing the tool. Another challenge encountered is developing of a GUI. I couldn't mostly familiar with command line operations of Python, but I couldn't bring myself to it just being a command line tool when the tool is very computer vision centric. I actually started off with WXPython, but once I had developed the GUI, I found that the GUI sometimes had trouble starting, at least in the particular version of Linux that I was running. So I opted, instead of trying to figure out exactly what the issue was, I ended up dumping it in favor of PyPQt4. Another challenge was just the sheer number of face recognition algorithms that are available. Ultimately ended up using Eigen Faces, but there are Fisher faces, as well as a few other more modern algorithms, and so ultimately I ended up choosing Eigen Faces because it's a well documented concept, and allow me to easily integrate into the tool. And the main purpose of, at least what I saw of the tool and being able to provide face recognition was the proof of concept. And the tool was developed modularly enough so that you could take out different functions and replace it with an up-to-date function that does a better analysis if so desired. Another challenge encountered was pre-processing of images. The face recognition algorithm actually requires that as an input, it receives very specific size and number of pixels, and so that presented to me a rather challenging problem, because not all the images that would be extracted would automatically be able to fit, hence pre-processing images, and luckily for me I was ultimately able to figure out how I could crop and then resize image so that it could be used effectively as an input for the face recognition algorithm. And the last challenge I encountered is actually recording of this video. This is probably the 5th time that I've been recording this video, and you would think that after a while I would become much better, but hence not. But there are many times where I would finish the video and it would fail to save. The size was too big, and so hopefully this one will prove to be a successful recording. Now let's go to the tool itself. The tool will come zipped up in the .zip format, and will contain the various files and directories that's listed here, and it could be installed anywhere the user desires. A little bit talking about what some of these items are. The evidence file is a directory that contains evidence, but the evidence files could exist anywhere on your hard drive. The database is actually the database that the face recognition algorithm will compare against. So if it, when it takes the input image, it will compare it against this database and try to match it as closely to one of these faces, which essentially the database is your list of I guess, for lack of a better word, criminals. That if it's a database of past criminal suspects or convicts, for that matter. And the two main files that are used to run the FaceDetector tool is FaceDetector.py and engine.py. Before going into it, in order to be able to execute the tool, there's a readme.txt that lists all the dependencies that are needed to be able to execute the tool and be able to run successfully. The one particular package that I found most troublesome installing was the PYQT4, and I found that ended up taking about 30 minutes to install, at least on my computer, which is not the most high bandwidth computer that exists out there. But if we take a look at the source code, FaceDetector.py is a tool that is a Python file that is used to execute the program. And if you take a look at it, essentially, really what it does, it launches the GUI window. And so the main meat of the code for the tool is in this engine .py, which at start contains the definition of what the size of the widgets are, essentially the GUI, and what it looks like, and sets it up. And you can see through, as we scroll through the code, all the various declarations to be able to set up the window. Now the tool is set up so that it is modular. It's essentially broken down into various different functions, and for example, perform analysis here gives you the ability to pick an analysis, and once you pick an analysis, it will launch that particular algorithm for analysis. And in our particular case, we have extraction, face detection, digit detection, and face recognition. As we scroll through the various functions, you see that facial detection is clearly documented as to where some of the source and some of the ideas came from for implementing, and then you'll see this repeated for the other functions, like the digest info group gives you essentially is the part of the tool that extracts the images and does the cropping of the faces, and also for digit detect, and at the end the last one is the face recognition, and it's pretty easy to read and modify if so desired. So one thing that you should keep in mind is this threshold here, and we'll come back and it'll make more sense what does that number mean when I execute the tool. So in order to launch the tool, at the prompt where FaceDetector.py is located, you type in Python FaceDetector.py, and when you do that, it will launch the GUI, as you see here, hopefully. scroll this down a little bit so you make sure it captures it. So as you can see, we have the file locator, the analysis with the various functions that you could execute, and start and quit. For our particular demo, the evidence file is under the evidence. This is called evidence.dd. We open that, and as the very first step is perform an extraction. Now, depending on the size of the image file, it may take a few minutes or longer. Like I said, depending on how many images extracting and how big the image is to begin with. The console here, you can see the progress as it's going through and processing the file. Once it is done processing, you will get essentially a digest info of what it did in this particular area. So you just have to wait until it's done, and it's telling you that it's started the analysis, and eventually it will come back once it's completed and display pertinent information to what it did. And in this particular case, it'll give you a timestamp, the name of the input file, the size. In this particular case, it was almost 1 gigabyte. A hashtag of that input file, the command that it used to execute, and in particular case, the extraction used foremost, which most of us are very familiar with, and in addition, all the various files that it processed, and where it actually saved these files. So if we go back here, evidence file, the directory that it chose to save the images that were extracted is based on the prefix of the input file added with out. So if you go in there, we see that there are two main directories, JPEGs and all the files that were extracted, plus another directory which is the pre-processing of these files, in which it crops the face that ultimately that we need to be able to use as an input for the face recognition algorithm. So once we have this, we could actually go back into the tool and check out what is it that it extracted, and what images it considers to have faces. So go to the directory, pick the first file, and it will actually scroll through all the files in that directory. We just have to pick the right analysis, and we click Start. And what it will do, it will scroll through the images, and as you can see, it puts on the left hand side is the input, and on the right is the overlay with a box over the faces. Now for the most part, it does a very good job of detecting faces, but occasionally you'll get a bad hit. But overall, I'm pretty satisfied with the capability of being able to detect faces, and so the vast majority of the faces were able to be detected. And the tool or the classifiers, you could tweak it either to raise or decrease the sensitivity of what it is that it would consider a face. So once the analysis is complete, that's mostly just to scroll through the images and see what the images that were extracted and which one actually contains faces. I had mentioned earlier digit detection, and like as I mentioned, that was outside the scope of the original intent of the program. But the reason I added it was I had the opportunity to do so, and also to demonstrate the extensibility of the tool. Digits, what I'm really referring to is being able to detect numbers in the image, but it could be extended to pretty much detect any type of object. You just have to be able to ultimately use the correct classifier or if you want to, you could also create a new classifier to detect a specific type of object that you're looking for. For this particular case, I'm going to run the digits analysis and see what we get. And what you find is that, well, doesn't seem to be doing a very good job. It tends to gives you way too many false hits, and that's mainly because of the training that it was originally given was a very low set of images to compare against, and hence it unlike this one actually did a very good job. If it finds an image has a lot of background noise and it's busy, it will have a hard time. So the background usually has to be uniform, and the numbers clearly visible in order to be able to do a good job, just like this one as well. But ultimately, like I said, this was just a freebie that added just so that I could be able to at least demonstrate to myself that if I want to, I could ultimately replace this particular analysis with anything else in case I want to detect some other type of object in the images. So that being done, I will as soon as this is done scrolling through the various images, I will demonstrate how the face recognition works. Now, in order to be able to perform a face recognition, and this was the only part of the program that I did not automate. I essentially ran out of time, but overall the tool is complete, and it does exactly what it is supposed to. So in order to be able to execute the face recognition, we want to go out to the directory that has crop faces, and pick one of the faces here, and you'll notice that I'm mostly picking we'll be picking the images that are gray. So part of the processing of the images was not only to extract the face, but also make it into a grayscale image, because that is another requirement of the face recognition tool, that it be grayscale. So if I pick that particular image and pick the analysis for face recognition, and I start, on the left hand side we have our suspect, and the right hand side we have a sea of unhappy faces or unhappy eggs, which essentially tells you that there was no match. The tool determined that it did not find a match as it looked through the database that was provided. And if we look here at the Euclidean distance, that's essentially what I referred to earlier, as in order to be able to be a match, that distance has to be as close to 0 as possible. Though the threshold can be selected, and for this particular tool, the threshold that I selected was 0.155, as I was scrolling through the source code I pointed out. So let's pick another image and see whether or not we potentially could find a match. And if we pick this one, we'll find that unfortunately no, she's not in the system, so she must be a law-abiding citizen. One thing I do want to show you is that what actually happens if you enter an image that matches exactly the what's in the database. And I'll do that. I'll show you that right now. So I pick this one, I run it, and lo and behold, is an exact match because the distance is 0. But obviously, never going to have an exact match if you're extracting images from a hard drive or some other type of digital backup. So is there anything or any image that was extracted, any of these people in the database that we could identify. And I'll pick a couple more. I'll pick this one, start, and lo and behold, we have a match. And according to the database, the suspect name is Nicholas Daly, and the colliding distance is 0.154, which is below the threshold that we had given it to be able to detect. Let's do one more to convince ourselves, and let's pick hopefully a law-abiding citizen that should not appear in the database, and hopefully we'll find that there is no match, and once again see that the distance is above the threshold, so there is nobody matching this particular feature, this particular face. So there you go, folks. This concludes my presentation of my face detector tool. I hope you find it useful and interesting. I certainly had a great time working on it, and hopefully in the future I could fine-tune the tool or add more features to it to make the tool even more useful. And hitting quit here will exit your program. Thank you so much.